changed. So nonetheless, most receivers incorporate a band select filter which selects the entire band, rejects the out of band. So to overcome this, I'm not going to change the frequency of my BPF. BPF means band pass filter. What I'm going to do, I'm going to use this BPF. I'm going to design the BPF for a band of frequency. So within this band, whatever signals will be taken in filtered. Outside this, the channels are going to be completely rejected. Okay. So I'm going to make my job simple. So whatever application I'm going to use a band select application, band select filter or band pass filter, where I'm going to filter out band of frequencies and I'm going to reject all the frequencies outside the band. See here, in the received band, I have one desired signal and two noises. Outside the received band, I have two noise here and one more noise here, which will be default removed. Now, after filtering, you see I have desired signal plus two noise alone. So at least I'm able to remove 50% of my noise using band select filtering. That is advantage I gain. Thus, we distinguish between out of band and in band interferers. So these two and this one is out of band interferer, and these two are going to be in band interferers. So the band select filtering will remove out of band interferers. It cannot remove in band interferers. So you have to have a trade-off between selectivity and band loss. So how can I remove this in band also? I have to make my bandwidth even more narrow so that only this channel I filter out. So that's what they say. You have to have a trade-off between selectivity and in-band loss. Because of having these two interferers, my power is getting lost. So I have to compromise between in-band power loss and selectivity. If I select only this channel, my power is saved. So selectivity and in-band power loss have a proper trade-off. So if you don't do that properly, then the entire concept of band selection will go wrong. And also see here, practical filters, ideal filters, you say this is the response. Sharp edges. But practical filters have this response. They have a small rising edge. They gradually increase, be constant, and then gradually decrease. So you cannot make it sharp. If you want to make it sharp, you have to use more number of filters or increase the number of filter sections or cascade more number of filters to ensure that these filters have a very sharp, they rise very sharp and they fall very sharp. Okay, so that is going to be difficult for me. Also, whatever extra in-band interferers is going to enter your low noise amplifier, it is going to raise the noise figure of the receiver. So the noise figure is increasing means it is not a good sign. So ideally, the noise figure should be 0 dB. But practically, they can go up to 1 dB. But because of in-band interferer, this noise figure will go beyond 1 dB. That is also going to cause serious issues in the receiver. So because of unwanted in-band interferers, my receiver performance is going to be degraded by a larger extent.